Hi everyone, welcome to my channel, Math with Miss Sabrine. In this video, we are going to learn about the change of base of logarithm and how to evaluate logarithmic expressions by changing the base. Let me start with an example. Log of 81 to a base of 3 gives us 4 because we already know 3 to the power of 1 is 3, 3 to the power of 2 is 9, 3 to the power of 3 is 27, but 3 to the power of 4 is 81. So the value of this is 4. Now let's see how we can get the same answer by using the change of base formula. What is this change of base formula? The formula to change the base is log of b to a base of a equals to log of b. This goes to the top and the base, it comes down. Log of b over log of a. So the formula is this, but let's say you want to change it to a base of x. Then you can write x in the place of base. I'm just going to write 1x. Now let's go back to our example, this thing, and use this formula to get the same answer. We had the first question, our question was log of 81 with a base of 3. I'm just going to follow this. So log of b, this thing goes to the top, which is 81, over log of, this goes down, over log of 3. Now let's say I want to change it to a base of 10. I'm going to write 10, and how to evaluate this? You can use your calculator to do that. Do you see the button log in your calculator? So just type that. If you type log, it just means the base is 10. So if you write log of 81, close the bracket, divide by log of 3, where is log? Yeah, divide by log of 3, you will get 4. This matches with this answer, so it proves that this change of base formula, it makes sense. Now the question is, why do we need to change the base? Because most calculators don't let you change the base. They have functions of log. If the base of that log is 10, which is also known as the common logarithm, and the functions of log with the base of e, it's called the natural logarithm, and the base of that is e. So we have this button in the calculator, log, and then we have this. The base of this is always 10 and the base of this is always e. So sometimes it's kind of hard to change the base in some calculators, so you can just change any questions to a base of 10 or to a base of e. You will get the same answer. So let's see how we can evaluate expressions like this. Let's say you have log of 20 with the base of 3. How can we use the change of base formula? I'm just going to follow this. So I am going to have log 20 over log of 3. And if you don't write any base, that means the base is 10. So you can just use the button in your calculator. You can type log of 20 divided by log of 3 and you will get something around 2.73. We need to use the change of formula for this kind of questions. It's because we don't know 3 to the power of what is 20. It's not like this type of questions. For this kind of things, you can just evaluate the expression right away. But what if you have a number and it's just not possible to find the power of this 3 that will give you 20? In cases like this, you are going to use the calculator. Now let's check our answer with a different base. So we are going to use the button ln in your calculator. I'm going to use the same example. The only difference is the base is going to be e in this case. So ln 20 of 3 equals to ln of 20. Now if you just write ln, the calculator assumes that the base is e. And also, like, the base of ln is always e. That's why it's called ln. Divided by ln 3, this goes down, and the base is also e. You don't really need to write it. Put it in the calculator, you will also get 2.73. So you can see how it's possible to use this log and this ln to evaluate your logarithmic expressions. And we use it for expressions where it's not possible to simplify by just doing mental calculations. So that's why you need to use this change of base formula. So it doesn't matter what the base is. If you follow the rule, you will get the same answer. Now let's think about the formula and why it makes sense. Let's say I have log of b with the base of a, and this equals to x. So we have this expression and you want to change it to a base of 10. If you want to change it to a different base, you need to get rid of this log first with this base, because you want to introduce a new base to this example. From this logarithmic form, I'm going to change it to an exponential form. We know how to do this already. I explained this in my previous video. This a will go to that side. This a will go to that side, kicks the x. The x is scared, so it jumps up and goes to the top, leaving us with b. So log of b with the base of a equals to x, and in exponential form it just means b equals to a to the power of x. Now I want to change it to a log of base 10. That's why I'm going to introduce log of base 10 to both sides. This side I will have log of b, this side I will have log of base 10 a to the power of x. According to the rule of log, this will go to the front. I also explained the rules of logarithms before. So this equals to x log a with the base of 10, and in this side we have log of b with the base of 10. How to calculate this x? You need to remove this and move it to the other side. So this side I'm going to have log of b over log of a. I don't need to write this 10 because it's if you write log and you don't write anything, that means the base is 10, equals to x. Now what was this x? This x was this thing, right? So we can also write this equals to log of a, base a of log of b with the base of a. This proves our formula that if you want to change this kind of expressions, log of b with the base of a, this always equals to log of b over a log of a. And whatever you want to change here, you can just name it anything. Let's say it's x. In this case, our example was with a base of 10. So this proves our formula. Okay, so that's all for today. If you like my videos, then please don't forget to subscribe. See you next time. Thank you.